Have you ever stood in a vast sweeping valley and wondered how it came to be? Or looked at a giant out-of-place boulder in the middle of a field and thought, how on earth did that get here? The answer, in many cases, is ice. Not just any ice, but colossal rivers of ice that once covered huge portions of our planet. These weren't just big, frozen chunks of water. They were geological powerhouses, sculptors of the very land beneath our feet. Today, we're going on a journey back in time to uncover how these ancient giants carved the world we see today. Let's start with the basics. What is a glacier? In simple terms, it's a massive, long-lasting body of dense ice that is constantly moving under its own weight. It forms over centuries in places where more snow falls each year than melts. As the snow piles up, the pressure from the layers above compacts the snow underneath, turning it into dense ice. Once it gets heavy enough, gravity takes over, and this immense river of ice begins to slide, creep, and flow. And it's this movement that unleashes its incredible power to reshape the Earth. Think of a glacier as giant sandpaper, or maybe even a colossal bulldozer. As it moves, it picks up rocks, gravel, and sand. This debris gets frozen into the bottom and sides of the ice, turning the glacier into an incredibly effective tool for erosion. This process is called glacial abrasion. The embedded rocks act like cutting tools, grinding away at the bedrock below, scratching, scraping, and polishing the surface. Over thousands of years, this relentless grinding can carve out entire valleys and reshape mountains. You can often see the evidence of this in the form of long, parallel scratches on bedrock, known as glacial striations. It's like finding the tool marks left behind by a master craftsman. But it's not just about grinding. Glaciers also use a brute force method called plucking or quarrying. As a glacier slides over bedrock, the water at its base can seep into cracks in the rock. When this water refreezes, it expands, acting like a wedge that pries loose huge chunks of rock. These rocks are then plucked from the ground and carried along by the ice, sometimes for hundreds of miles. This combination of abrasion and plucking is what makes glaciers such formidable agents of change. They don't just smooth the landscape, they actively tear it apart and rebuild it somewhere else. Perhaps the most iconic landform created by glaciers is the U-shaped valley. Before the ice ages, many mountain landscapes were characterized by V-shaped valleys, carved by the downward cutting action of rivers. But when a glacier moves into one of these valleys, it's a whole different story. Unlike a narrow river, the thick, wide glacier fills the entire valley from side to side. As it grinds its way forward, it scours the valley floor and erodes the sides, straightening, widening, and deepening it. The result is a classic steep-sided, flat-bottomed U-shape. The next time you see a picture of Yosemite Valley in California, or the Lauterbrunnen Valley in Switzerland, you're looking at a masterpiece of glacial sculpture. And what happens when these U-shaped valleys are near the coast? You get one of nature's most dramatic features, the fjord. A fjord is simply a U-shaped glacial valley that has been flooded by the sea after the glacier retreated. During the Ice Age, global sea levels were much lower because so much water was locked up in ice sheets. This allowed glaciers to carve their valleys far below the current sea level. When the ice melted and the seas rose, these deep troughs were inundated with seawater, creating the stunning, deep and narrow inlets we see in places like Norway, New Zealand, and Alaska. They are a direct testament to how profoundly glaciers have influenced our coastlines. Now let's talk about those mysterious out-of-place boulders I mentioned earlier. These are called glacial erratics. They are rocks that have been picked up by a glacier, carried sometimes hundreds of kilometers, and then dropped in a new location when the ice melted. The fascinating thing about erratics is that their rock type is often completely different from the bedrock of the area where they are found. Geologists can use them like geological breadcrumbs, tracing them back to their original source to map the path of ancient ice flows. So that giant boulder in the middle of a flat prairie isn't a mystery. It's a postcard from a long-vanished glacier, a heavyweight souvenir from the Ice Age. The creative power of glaciers doesn't stop there. When a glacier melts, it has to drop all the rock and sediment it was carrying. This material is called glacial till. The ridges of till that form at the edges and end point of a glacier are called moraines. A terminal moraine marks the furthest point the glacier reached, like a giant earthen wall. You can find these features all over the world. In fact, Long Island in New York and Cape Cod in Massachusetts are essentially massive terminal moraines left behind by the Laurentide ice sheet. The land itself is a deposit from an ancient glacier, from a continental scale down to a single scratched rock. The fingerprints of these ancient ice giants are all around us. The Canadian Shield, one of the world's oldest geological formations, was scraped down to its bare bones by repeated glaciations, leaving behind a landscape of exposed bedrock and countless lakes scoured out by the ice. The mountains of Scandinavia, the Scottish Highlands, and the southern Alps of New Zealand all owe their dramatic, rugged beauty to the carving power of glaciers. They are landscapes born of ice. Even the soil in many of the world's most fertile agricultural regions is a gift from the glaciers. As glaciers ground down mountains, they created a huge amount of fine-grained sediment called rock flour. This material, along with other glacial deposits, formed the parent material for the rich soils of the American Midwest and the plains of Northern Europe. So in a way, the bread on our tables has a connection to the immense grinding power of ice that existed tens of thousands of years ago. It's truly humbling to think about. These slow-moving, silent giants have had a more profound impact on the surface of our planet than almost any other natural force. They are both destructive and creative, tearing down mountains and building new lands. They've dictated the paths of rivers, created lakes, and sculpted coastlines. So the next time you're out in nature, take a closer look at the landscape around you. You might just be standing in the footprint of a glacier, a silent reminder of the awesome and enduring power of ice. Thank you so much for joining me on this geological journey today. If you found this as fascinating as I do, please hit that like button and subscribe for more adventures into our amazing world. Let me know in the comments which glacial feature you find most impressive. See you next time.